Hello and welcome to this session on inverse functions. I wanted to start by getting you to have a little look at the following question. Now, I want you to find the inverse function of both this one and match it to the correct one. If you pause your screen and have a go at that now, that would be brilliant. Okay, so in order to do the inverse functions, we start by changing the f of x for y. So for both of these, I'm just going to change the f of x section to a y. We then make x a subject, and that's what this misconception is all about. On this one here, we have to add 1 to both sides to start with. So therefore, we get y add 1 is equal to 4x. However, on this one, because the 4 is multiplying both of those terms in the brackets, we actually divide by 4 first. And so therefore, we get y over 4 is equal to x minus 1. Now, you can see that these suddenly now look quite differently. Here, we're going to have to divide by 4. And so therefore, we get y add 1. Now, all of that has to be divided by 4 because you're dividing both terms on that side of the equal side by 4 is equal to x. And on this one, we're adding 1 to both sides. So therefore, you're going to have y over 4 add 1 as a separate term on that side of the equal sign. And then to complete our inverse functions, we change the y for x and the x for f of minus 1x. Again, on this side, we change the y for x and the x for f minus 1 of x. So we can see that this one here is equal to a, and we can see that this one here was equal to b. So as a result, that misconception about the order in which you do things is really, really important when it comes to functions. Remember, this one we divided by 4 first. Here we added 1 first because the 4 is only multiplying the x on this side, but it is multiplying everything on that side. Now, in order to ensure you've understood that, I'd like to have a go at the following question. If g of x equals 3 add 2 of x, what is g minus 1 of x? Pause the screen and have a go at that now. Now, if you did this correctly, you should have ended up by having the following. Y is equal to 3 add 2x. We then take away 3 to both sides, so y minus 3 is equal to 2x. And then we divide by 2 to both sides. So therefore, y minus 3 over 2 is equal to x. We then make sure we do the following. In fact, look really carefully at my answer. What mistake have I made? I've replaced the x for g minus 1 of x. However, what is wrong with this solution? Have a little think about that now. Now, if you got this correct, you'll notice it's because the y also needs changing to an x. So that should be x minus 3 over 2. And now we have our correct solution. So another common misconception is to leave that y and not replace it with the x. Remember, in our original function, there was no y. So therefore, there has to be no y in our solution. Okay? Right. If we then also move to our very final misconception, a really, really common misconception, and it starts with this question here. Okay? We have the following. F of x is equal to x squared add 16. Now my question is, when we do f minus 1 of x, is this equal to I've got one more misconception for us to look at. Look at the function here. If we find f minus 1 of x is equal to the square root of x minus 16, is it equal to the square root of x, then minus 4, or is it equal to both? So, pause your screen now and have a go at it if you can. Now, we start with this in the same way. We change the f of x for y equals. So we get y equals x squared add 16. We then take away 16 from both sides. So we get y minus 16 is equal to x squared. And then we square root both sides. So we get the square root of y minus 16 is equal to x. We then replace our terms. So we replace the y for x, and we replace the x for f minus 1 of x. Now I'm going to write this in the correct order so you can see it matching the answers to your left. Now we can see it definitely equals a. Now, the question is, does it equal b or not? Now, the answer is no. We cannot square root terms that are separate and that both lie underneath that square root symbol. I'll show you a quick example so you can understand why. Let's imagine that x is equal to 36. Well, then the square root of x subtract 4 would give us square root of 36 is 6, and 6 subtract 4 gives us an answer of 2. Now let's suppose x is 36 still, but then let's substitute it into this. If x was 36 and we substituted it into x minus 16, all square rooted, we just get the square root of 10, because 36 take away 16 is 10, and the square root of 10 is not the same as 2. Therefore, they are not the same. As a result, it does not equal b, and that's another common misconception, that you can square root a square number in a square root sign when it's being added or taken away from another term. Thank you very much for listening, and I hope that's helped with some of the misconceptions around inverse functions. Bye.